we're back looking at vectors again. So previously you looked at how to calculate the magnitude of a vector and how to perform various operations on vectors and what a vector even was. So we're going to build on that. So starting off, a unit vector. So a vector u with length, remember the bars represent magnitude, with magnitude of 1 is a unit vector. So the idea, if a vector has length 1, it is classified as a unit vector. Okay? So how do we find a unit vector? Like if I have one vector, how do I work with that? So if vector v is not the 0 vector, then its unit vector, I'll add here same direction. So I shouldn't say this, they're not the same vector because their magnitudes are going to vary, but they're going to be in the same direction. Its unit vector is, or can be found by the vector, the component form, divided by the magnitude of the vector. So another way that we're going to write this, and most often use this, is 1 over the magnitude multiplied by the vector. Okay? So this is how we calculate a unit vector. Put a nice little box, some good stars around it because we're going to be using this a lot. So let's take an example for a moment. So find a unit vector in the direction of -3, 2, and verify it has length 1. Well, if we use the formula here, it should have length 1. Let's just test it out. So the very first thing we need to do to find the unit vector is to find the magnitude of this vector. So, okay, we've learned previously that given the component form, magnitude is really easy to calculate. -3 squared plus 2 squared, that's going to be 9 and 4, so square root of 13. That's the magnitude. Now to find the unit vector, we're going to write this down again, 1 over this and multiply by this component form. So we get 1 over square root of 13 multiplied by -3, 2, okay, which is -3 over square root of 13, comma, +2 over square root of 13. Okay, and here we have our unit vector. So based off of the formula, this should have a magnitude of 1. How do we find magnitude of a component form? Well, we just did it here. So we're going to take each of these components, square them, add them, and it should come down to just 1. Let's test it. All right, so the magnitude of this. Okay, so let's see. We take the square root and we square the first component, adding to it the square of the second component. Extend this a little bit. All right, so that would be square root of +9 over 13, and then +4 over 13. Simplifying that comes down to, well, common denominator, so it would be 9 and 4 is 13 over 13, which is 1. So, hey, yes, we see that the magnitude is, in fact, 1. So just summarizing this for us, we're going to say that this vector, -3 over square root of 13, comma 2 over square root of 13, this vector is a unit vector in the direction of vector v. Okay, just a good summary statement for that problem. Moving on, so remembering this formula throughout this video, and let's see what we got. So, yes, we've talked about unit vectors and what they are. Here we actually have another subtopic, that being a direction angle. You already know what a magnitude represents, that it's the vector's length. Now, we did not talk about the direction of the angle, what we can use to represent it. So a direction angle, looking at the definition, is the angle that the vector v makes with the positive x-axis. So the x-axis would be 0 degrees, and you're just rotating around, much like the unit circle. Okay, so in this, so we have a vector v1, v2. That would tell us that this coordinate is v1, v2. Now, breaking this down into components, I have written here that the length is the magnitude of the vector. We don't know what the vector is. So, I imagine I drop a vertical line down. The horizontal piece here of this right triangle, using trigonometry, it would be, if you calculate it out, it's going to be the length of the hypotenuse, well, we know that to be just the magnitude, multiplied by cosine of the angle. That's the horizontal piece. And then the vertical piece, using trigonometry, it's going to be the length of the hypotenuse, or the magnitude, multiplied by sine of theta. So what we're doing with this is we're going to rewrite now, or rethink component form v1, v2. We're going to think of this actually as the magnitude of v multiplied by cosine of theta, and the magnitude of v multiplied by sine of theta. All right, so this is another form, another way of writing the component form. And really, you're only going to see this when we know, or we're looking for, the direction angle, okay? So understand that this first piece, this is our horizontal component, hence cosine, and we have our vertical component, hence sine, okay? Now, the theta you see here, the theta in this is the direction angle. In both of these, okay? So that's, with this, knowing how we can rewrite the component form, let's look at a problem and examine how we can use direction angles a little bit. So find the components of vector v with the direction angle of 115 degrees and a magnitude of 6. So notice the difference with this problem compared to previous ones. Here, we do not know what the horizontal and vertical movement is. Based off what we're given, we have the direction angle that gives us, where the vector is pointed to, and we have the size of the vector, the magnitude of it. So magnitudes, they'll always be positive. So that doesn't really tell us what quadrant we're in. The angle does. The angle tells us what quadrant we're in. So using our component form, let's see, horizontal component, that's magnitude. So that's going to be magnitude times cosine of theta, or in this case, 6 times cosine of 115 degrees. And then the vertical component is going to be the magnitude multiplied by the sine of theta. So it's going to be 6 sine of 115 degrees. Yes, you could evaluate these and get an approximate of what these equal, but it is always a good habit to never give approximates unless asked for. So our component form is 6 cosine of 115 degrees, comma, 6 sine of 115 degrees. All right. So Not much to it. It's just, again, knowing definitions and working with it. Believe it or not, this is our last example. What is different, if you take a look at it real quick, it's the exact opposite question of what we just had. The problem we just came from, I gave you the magnitude and I gave you the direction angle, and I asked for the components. Here, I give you the components and ask for magnitude and direction. So magnitude is very easy. So the magnitude of u is going to be the square root of 3 squared plus 2 squared. Okay, it's going to be 9 and 4, so square root of 13. All right. And then the component, the direction angle is going to be not as straightforward. Okay, so knowing and remembering that the alternate form of vectors is magnitude times cosine, and then magnitude times sine. What we're going to do is set this part, or even this part, equal to what we're given. So we're going to set the magnitude times cosine of theta equal to 3. And I could take this approach using magnitude times sine of theta. I would just be setting it equal to 2. Okay? Now working with this, we're trying to find the angle. That's our goal here. We want the directed angle. So we just found the magnitude, square root of 13. Okay, solving this, trying to get cosine by itself. Cosine of theta equals 3 over root 13. This is not on our unit circle, so we're going to have to use our calculating device. Oh, pre-calc is the best. I know. So inverse cosine, or arc cosine of 3 divided by root 13. And we get, we're going to get error there. There we go. We get approximately 33.6901. So our cosine of root 3 over root 13 is approximately, as I said, 33 degrees, 0.6901 degrees. And we have to pay attention here. Is this angle appropriate for our vector? Okay, so let's think about what our vector looks like real quick. So our vector, we could assume it's from the origin, 0, 0, going out to 3, 2. Okay. So, does it make sense to us that this angle measure is 33.6901? It should make sense. Why? Because our vector is in quadrant 1, hence our angle that we get is in quadrant 1, so that's good. So before moving on to the last example, I want to just remind you that we could have used I said this before, magnitude times sine of theta, we could have set that equal to 2. We could have done that. You would have gotten the same exact angle measure. Okay? So with that understanding, knowing how we set one of the components equal to its alternate form, and just solved here using either arc cosine or arc sine, depending on what approach you took, and giving us our angle measure, being sure to check to see, does the angle match up right with the vector? So take a shot at this last problem, guys. Pause the video and find the magnitude, which should not be difficult, but then find the direction angle. So pause now and work it out. Okay, so how'd you do? Magnitude, rather simple, should be square root of 29. choosing to use the horizontal component, we worked it out and saw our cosine of -2 over root 29, that equals 111.8014 degrees. Now, I chose to not continue here. Maybe you figured out there's more to this problem. But we need to talk about what quadrant our vector is in. So thinking of the horizontal and vertical components, this vector, -2, -5. Okay? This vector's in the third quadrant. What quadrant is our angle in? Yeah, our angle is in quadrant 2. That's not good. Okay? So we need to find what the actual angle is. The reason why it's not giving us, just so you know this, the reason why it's not giving us the true angle is because the output, the range of arc cosine only goes from 0 degrees to 180 degrees. So anything past 180 is going to require some additional work from us. So what we can do here is we could take this obtuse angle and subtract it from 360 degrees. Which, doing that difference, we get 248.1986 degrees, and this is our theta. This is our directed angle. Okay, and if it was in, if my vector was in quadrant 4, chances are my angle that we would get. The chances are the angle would be in quadrant 1, so you again just take 360 and subtract what you have. So in this lesson we talked about what is a unit vector and how do you find it. We talked about what is a direction angle and how do you find it. So I wish you the best of luck, guys, continuing working on this, getting better at it, and we're going to continue on with vectors and what we can do with them. So best of luck, and I'll see you in the next video.